Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. One previous topic is left related to relay used in PLC circuit. This is the internal construction of a relay circuit. So how many types of coils are there? Then the types of switches generally used inside the relay, then contacts. All these things are discussed in this topic. So basically, relay means what? What the relay performs. All these activities are comes under this point, that is relay. Sometimes this relay is also called as contactor in the language of the PLC. So early electrical control system were composed of mainly relay and switches. Relay is also one type of switch. The switches are familiar device, but relay may not be so familiar. Therefore, before continuing our discussion of machine control, ladder diagramming, a brief discussion of relay fundamental may be beneficial. A simplified draw of a relay with one contact is shown in figure. Note that this is a cutaway or a cross section view of a relay. A relay or contactor is an electromagnetic device composed of a frame or core with an electromagnetic coil or contact. Some coils are movable and some are fixed. A movable contact and conductor that connects are mounted via an insulator to a plunger which moves within a bobby. A coil of a copper wire is wound on a bobby to create an electromagnet. A spring holds the plunger up and away from an electromagnet. When the electromagnet is energized by passing an electric current through the coil, the magnetic field pulls the plunger into the core, which pulls the movable contact downward. Two fixed pairs of contacts are mounted to the relay frame on electrical insulators so that when the movable contacts are not being pulled towards the core, I am repeating, two fixed pairs of contacts are mounted to the relay frame on electrical insulators so that when the movable contacts are being pulled towards the core, the coil is de-energized. They physically touch the upper fixed pair of contact and when being pulled towards the coil, touches the lower pair of fixed contact. There can be several sets of contact mounted to the relay frame. The contacts basically energize and de-energize as a result of applying the power to the relay coil. By referring this figure, when the coil is de-energized, the movable contacts are connected to the upper fixed pair. This pair is a contact pair. And these fixed contacts are referred to as a normally close contact because they are freed together by the movable contact and conductors whenever the relay is in its power of state. Likewise, the movable contacts are not connected to the lower fixed contact pair when the relay coil is de-energized, and these fixed contacts are referred to as the normally open contacts. These contacts are namely with the relay in the de-energized state, and normally open contacts are said to be off when the coil is de-energized and on when the coil is energized. Normally closed contacts are on when the coil is de-energized and of when the coil is energized. Those that are familiar with digital logic tends to think of normally open contact as non-inverting contact and normally closed contacts as inverting contacts. Now there are some types of the relay system, that is time delay relay, and it is possible to construct a relay with a built-in time relay device that causes the relay to either switch on after a time delay or to a switch off after a time delay. These types of relay are called as time delay relay or TDR. The schematic symbols for a TDR coil and contacts are the same as for the conventional relay. Also, time on or delay on timer, that is TON relay, is also used in PLC system. Let us see, when an on timer is installed in the circuit, which circuit is the ladder circuit, the user adjusts the control on the relay for the desired time delay. This time setting is called as the preset time of the PLC. And notice that on the top waveform that we are simply turning on the power to the relay coil, and some undetermined time later, the turning it off means the amount of the time that the coil is energized and makes no difference to the operation of the relay. When the coil is energized, the internal timer in the relay begins running. When the timer value contained in the timer reaches the preset value, this relay starts to energize. And when this happens, all normally open contacts on the relay closes and all normally closed contacts on the relay gets open. Also notice that when the power is removed from the relay coil, the contact immediately return to their de-energized state and the timer is reset and relay is ready to begin the timer again and again. The next time the power is to be applied. If the power is applied to the coil and they switch off before the preset time is reached, the relay contact never be activated. Here, this delay on relay are useful for delaying the turn on event. And for example, when the motor is started on a machine, a T on time delay relay can be used to disable all the other control for a few seconds until the motor has the time to achieve the running speed. Thank you.